35. To be honest, I don't know. It doesn't like match up to any of the others that we've looked at just yet, so I can't say like, oh yeah, it's going to be just like this one or just like that one. So I want to start with what I can see, and I don't know if it's going to be a good approach or not, but sometimes that's what you got to do. So I'd say, well, maybe if I change this to like a 1 over sine, that's a little bit better because now my equation only has sine in it. But I really don't want to try to solve an equation that has fractions. So I think what I would probably do is I'd either add these two together, get a common denominator and add these fractions, or I would just multiply both sides by sine. And I think they're both going to achieve the same goal. So, okay, if I multiplied both sides by sine, this would be 2 sine squared, I'm distributing. Sine times 1 over sine would just be 1. And 0 times sine would still be 0. Now I do have to put a little asterisk here. Doing that may create an extraneous solution. So it's always a good idea to plug in your answers at the end to make sure that they work, but in this case I think it's necessary. I think multiplying both sides by sine might give us a fake answer. But that makes it to where at least now it looks a lot like question 15 and 17. It's kind of fitting the pattern of other questions. We could subtract 1 and divide by 2, take the square root of both sides, which should be plus or minus. And that's going to be a problem because square rooting a negative number is how you get imaginary numbers like I, but that's not something we're interested in dealing with here because we're only interested in real numbers. So I'm going to go on a limb here and say that this is not possible. Does anybody have access to the online answers or the back of the book? Can check in 5 seconds. Not possible? Yeah, so algebraically, you know, I did what I could, and then I would say 99% of the time, if you guys have the square root of a negative number, you've made a mistake. Like something in your work, you shouldn't be dealing with that. But in this case, everything looks good, and that is imaginary, and we're only interested in real numbers, right? Unit circle, we don't talk about values of I or anything like that. The other reason why I kind of had a suspicion this was going to be the answer is because these are reciprocals of themselves, right? So if this is positive, that has to be positive. Does that make sense? Reciprocals don't change signs, they just flip over. So if you took something positive and added something positive, it's never going to be 0. Or if it was negative, something negative minus or plus something negative would also never be 0. So just the fact that they're reciprocals kind of gave me a clue too that there was no way that that was going to ever get to 0.